section 1.6 is on describing pairs of angles. And some of those angles we wanted to have some other information with us, so we put together our little foldable here. And we want to talk about a few of them in particular because they're new to us. So acute, obtuse, right, straight angles are all things that we discussed the other day. But we want to talk about complementary angles and supplementary angles. So who has a good definition of complementary angles? Yep, on that other sheet. So back to your other sheet real quick. What was your definition of complementary angles? Good. The measures add up to 90 degrees. So don't worry about whether they're positive or negative. We won't give you negative angles. But the big thing to remember about complementary angles is that their sum is 90 degrees. Make sense? Okay. So when I go to a hotel, I think about, oftentimes they have a complimentary breakfast. Okay, they've gotten pretty elaborate over the years, but in the past it used to be some cereal, a bagel, a donut, something small, right? When you think of complimentary, someone's giving you a small compliment, okay, something not very large. So think about 90 as being something smaller, and complimentary goes with that. Does that make sense? Okay, so who has a good definition of supplementary angles? You all do. You took them from the book, right? What are you going to remember when we hear supplementary angles? Yes. Sum of 180 degrees. Now, I'm a farm girl. We don't do lunch. Okay? We have breakfast, we have dinner, we have supper. Okay? Because on a farm, you work hard. You do a lot of physical activity, right? A lot of lifting, moving, carrying things, and so forth. So you don't mess with a puny little lunch. Okay? You have a big dinner, right? Dinner at noon is meat and potatoes and a vegetable. And then you turn around and have supper, and supper is meat and potatoes and a vegetable and pie or some kind of dessert. Make sense? So supper is big, supplementary, 180. That makes sense? Okay? Complementary, small complements, 90 degrees. Supplementary, big, like supper, 180 degrees. Does that help? And the other way to think about it is C comes before S in the alphabet, right? So C would be smaller, it's 90, S is 180. Okay? So find something that makes sense to you to help you distinguish between the two. Because later on we're going to ask you if we have two complementary angles, you have to think, was complementary adding up to 90 or was it adding up to 180? Make sense? If it helps, write it in your notes. Okay, then the other two things that we want to talk about. Well, congruent angles, easy enough, right? Remind me what congruent angles are. Congruent meant same size, same measures, right? Okay. And then adjacent angles is one that we want to talk about as well. And I may have mine out of order. I think your sheet has the adjacent down below. Makes more sense to talk about adjacent before we talk about two adjacent angles that are a linear pair. Okay, so what are two adjacent angles? How are we going to define them? Nathan and Jacob sit adjacent to each other. What does that mean? Next to, okay? Is Nathan adjacent to Jaden? No, okay? So they have to share some common space, right? Some common area. So when we think about adjacent angles, we want to think about two angles that have a common vertex and ray. Does that make sense? But that ray has to be between the two. So far, so good? Okay. So angle ZXY is adjacent to angle YXW because they share a ray, don't they? And that ray is between the two angles. So if that is a better definition than what your book says, We can write that down. Okay. Two adjacent angles share an array and a vertex. The ray is between the two angles. Okay. I think we can see it and know it and look at it and be fine with it, but our book actually comes up with a definition for adjacent angles that say adjacent angles are two angles that share a common vertex and side, but they have no common interior points. No common interior points. Okay, that means they don't overlap. Does that make sense? Because angle ZXY and angle ZXW share a common ray, don't they? Okay, but ZXW has common interior points with ZXY. Okay, so I'm never going to ask you for a formal definition, but I want you to have a working definition in your mind that makes sense to you. Okay, adjacent means next to, not on top, not overlapping, right? They only share a ray, one common ray in the vertex. Okay, do you have any questions about adjacent angles? Make sense? Okay, in order to understand then what a linear pair is, you have to really understand what adjacent angles are. Okay, so linear pair, when you think of linear pair, what word comes to mind when you think of linear? A line. Okay, so linear pair means a pair of angles that form a line. And if that's your working definition, by all means use that. Okay, but our book says that two adjacent angles are a linear pair when they share a common vertex. Their non-common sides are opposite rays. Their non-common sides are opposite rays. That works, provided you remember what opposite rays are. What was a definition, a working definition of opposite rays? We talked about your parents maybe being frazzled because they've got you and a sibling, right, going in opposite directions some days, right? What does that mean? You're going, yeah, two different ways, right? Maybe north for one thing and south for another, heading to Lincoln for something and Council Bluffs for something else, right? Opposite directions, right? So when we talk about opposite rays, what do those two rays form? A line, okay? So if you want to think about two adjacent angles or a linear pair as two angles that form a line, a straight line, by all means that works. Does that make sense? Okay. And then we need to talk about vertical angles. Vertical angles, we have a formal definition from our book. It says that vertical angles have sides that form two pairs of opposite rays and they only share a vertex, right? Okay. Two pairs of opposite rays, okay? When I think of vertical angles, I think of a cross, right? We've made an X of some sort, and the only thing they have in common is V for vertex. Vertical angle, V for vertex. Okay. So let's number our angles here. Let's put a 1 here, a 2 here, a 3, and then a 4. So we've got 1, 2, 3, 4. What angle is vertical with angle 1? 3. Why? Opposite side only shares a vertex. Make sense? What angle is vertical with angle 2? 4. Because they only share a vertex. Is everybody cool with that? Okay. So we intersect two lines, we make 4 angles, and if they are exactly opposite each other, they only share a vertex, they're vertical. Okay? All right. So let's see how we can do. Now we're on our notes sheet. Okay. First question asks you to name 2 complementary angles. So remind yourself what complementary angles are, just like a complement and complementary breakfast. And then write down 2 angles on your paper that are complementary. Remind me, what does complementary mean? Sum up to 90 degrees. So find 2 angles in that first box that will add up to 90 degrees. Do you have this note sheet? It looks like this on the back. 1 5 on the back and 1 6 on the front. Yep, the back side is what we're working on today. Would it help if I gave you a folder? Okay. There you go. If you can't find it, let me know. I've got a spare. Okay. All right. Got answers down. That's good. So what do we think our 2 complementary angles are? You want to volunteer? Which 2 add up to 90? So CBA, I love how you named that. Why did he name that correctly? C had to be the middle, right? Could he have called it just plain old angle C? Why? How many angles are here? Just 1, right? So he could have called it, sorry, it said C, I meant B. He could have called it angle B as well, right? Okay, and which other one, Jaden? So 28 adds, and what adds to 62? Or adds to 90. HIK? Not quite. Careful. You said it correctly in order, but what is 28 plus 72? 100. So we're a little bit over. So which one? FEG. Can she name this just plain angle E? Why not? There's at least 2 angles, if not 3 here at angle E, right? So she had to use the 3-letter combo. She made sure her E was this middle one. The vertex is always the middle of the angle name. Good job. All right, next one. We're asked to find a pair of adjacent, sorry, not adjacent angles, a pair of supplementary angles. So keyword supplementary, it's like supper, right? Big meal. So what does that mean? 180, they have to add to 180. You're ahead of me. So which ones did you get? Good job. DEG and HIK. DEG and HIK. I'm just going to call that angle I. I'm going to be lazy. One angle, one letter. But multiple angles, we have to use the three-letter combo. Everybody get those two? Okay. Speed it up. You guys are ahead of me. I'm taking too much time. A pair of adjacent angles. What do you have, Hannah? Which ones are your adjacent angles? Good. Name them for me. GEF. I like it. And GEF is adjacent to which one? Let Hannah finish. You can do it. What are we going to name this one? It's okay. We started with GEF, right? Which you have. So now we want, they have a common side. So that side is G, right? Good. I'm going to cold call people. My son works at Gallup, and he works as a surveyor. So he cold calls people, which means that he gets their number, and he has to make phone calls and ask them surveys. Okay? I'm going to do the same with you all. As I get to know your names, I'm going to cold call you to make sure that everybody has a chance to have a voice, right? There's nothing worse than being in a class all day long and never getting called on or never ever answering a question or being able to ask a question, right? All right, so here's the tougher ones. Okay, think about complementary angles. Angles 1 and 2 are complementary. What does complementary mean? Add to 90, okay? Angle 1 is 62 degrees. How are we going to find the measure of angle 2? Absolutely. Subtract from 90. So what'd you get? 28 degrees. Good job. Okay, next one. Angle 3 and angle 4 are supplementary. Angle 4 measures 47 degrees. What's the measure of angle 3? How would we find it? Good. Why is it 133? Good. So 180 minus that 47 gets us 133. Not hard math. We just have to know what these words mean, right? All right. The next one. We have the veins of a leaf. Those veins of a leaf form a pair of supplementary angles. The measure of one is 7x plus 13. The measure of another is 2x, 25x plus 7. Kind of hard. The leaf is kind of small, so it may not hurt to redraw it off to the side. Angle 1 measures 7x plus 13. Angle 2 measures 25x plus 7. So geometry is just like algebra, only we have to come up with our equations first. Then we solve them just like we did in algebra. So what do you think? What's an equation that we can use to solve to find out what x is? Absolutely. 7x plus 13 plus the 25x plus 7 has to add up to 180. Because they're a linear pair as well, right? Now what do we do with something like that? Now we've got our algebra problem. How do we solve it? Combine like terms. Like terms are 7x and 25x. We add them and we get like terms are also 13 and 7 since they're on the same side of the equation. What do we get? 32. Thank you. Okay. So 32x and 20. 32, yes. Okay, now what do we do? Take away 20 from both sides. So 32x equals 160, right? And then we divide. What do we get? 5. So are we finished? No. Hardest part is getting the equation set up, right? And the second hardest part is remembering to plug it in. So what is, this is easier probably to multiply, right? What is 7 times 5 plus 13? So we have 48. If that one's 48, how can we find the other one? Subtract from 180. Or take 25 times 5 and add 7. Okay, so we get 48 for this one. And how much for the other? 132. What questions do you have about this one? Does everyone see where we came up with that equation? Okay. All right. I think we have just 2 more quick examples, making sure we understand what vertical angles are and what linear pairs are. Going to have a lot more linear pairs than we will vertical. So we want to identify all the linear pairs and all the vertical angles in this figure. And we were nice and didn't give you 3-letter combinations here. This is where we like to use numbers to quickly identify angles. Okay? So let's go with Zach. Can you name a pair of linear pairs for me? We've got 2 Zachs. I'll pick on the other Zach first. 4 and 8. Okay? Are 4 and 8 2 angles that form a straight line that are adjacent to each other? Mm-hmm. 1 and 2. I like 1 and 2 better. So a linear pair involve angles 1 and angle 2. Do you see that angle 1 and 2 form a straight line and they have a common ray that's between them? Okay. So that was 1. Now let's pick on the other Zach H. What's another pair of linear pairs? 4 and 3. Okay, does everyone see that 4 and 3 also form a straight line and they have a common ray that's between them? Okay. Now let's pick on Andre. What's another pair of linear pairs? 5 and 6. Everyone agree that 5 and 6 are a linear pair? Okay. And then let's pick on Spencer. What do you think? 8 and 7. Okay. So that's another linear pair. Are we finished? Can we find more linear pairs? Okay, Spencer found another. 8 and 5. Why are 8 and 5 a linear pair? Yeah, just the other way. They still form a straight line, but they have one common ray that's between them. Okay. So let's pick on Claudette. What's another pair of linear pairs that we haven't said so far? 6 and 7. Good job. And I don't think I've picked on Callie for a while, so Callie, what's another pair for me? Kaylee, I'm sorry. Said your name wrong. What's another linear pair? Okay, we started going down this road and we got 8 and 5 and 6 and 7. But I don't think we've done anything this way. Can you find one for me? I'll come back to you. Let's try Erica. Erica, what's another pair of vertical or linear pairs? 3 and 2. All right, Kaylee, she had 3 and 2. Can you come up with that last pair for me? Promise it's not painful. You can do it. Okay. I have a volunteer in the back who's going to rescue you. Olivia. Not okay. Olivia didn't volunteer. Try Faith. 4 and 1. Okay. So far, so good. Now, vertical angles. Remind me, what are vertical angles? Made with 2 lines, right? Only share a vertex. V for vertex. V for vertical, V for vertex. Okay? All right. So now, let's this time go ahead and pick on Olivia. Can you tell me one pair of vertical angles? 2 that only share a vertex. Very good. 4 and 2 only share a vertex. Okay? They're 2 angles that share just a vertex, one common vertex. Once you get on a roll, it gets easier. Okay? I haven't picked on Ariel yet, so what's another one? 3 and 1. Okay. And I know I haven't picked on Dara yet, so what's another one? 8 and 6. Nice thing is we're almost done with this one because there are only 4. Okay. And I know I have not picked on Hannah Parks yet. So Hannah, 5 and 7. Make sense? All right. What questions do you have on this slide? Feeling good about it? All right. Last one. Everybody stretch if you want to stand up a little bit. Get the blood flowing again. It's all landed in our backsides because we've been sitting down, right? Got to use some blood flow for brain matter here. 2 angles form a linear pair. Okay, I want everybody to stretch. Reach up, stretch. Don't hit anybody near you, but stretch. Okay. We have 2 angles that form a linear pair. The measure of one angle is 8 times the measure of another. Find the measure of each angle. Our book likes to give you a word problem like this. So what do you think we should do? How should we start it? Any suggestions? No, you're coming up blank, sorry. What's the key word here? Ariel. Linear pair. Keyword linear pair. Do we know how to draw a linear pair? When you get these problems, draw it. It will help. Okay? So everybody draw a linear pair. I've got my line. It is on my website. Did you? Okay, give me a second. Let me finish this real quick. I'll be right with you. Okay? So linear pair, we draw a line first, right? Okay? And we draw one other ray coming off, right? Everybody agree that's a linear pair? Okay. So what are we going to do with that then? we have one angle that's 8 times the measure of the other angle. So let's let one of them be x. Everybody cool with that? Okay, if one of them is x, then if the other one's 8 times as big, what does that mean? 8x. Once you have a picture, I think you can figure it out from there. But the hardest part is drawing a picture. Okay, so Andre, what would my equation say now? You can do it. I have faith in you. 8x equals x plus x equals, good, 180. Okay, I put him on the spot and he did well. Okay, now you know how to solve it, right? Okay, so your assignment is going to be, this is for tomorrow because we took a long time talking about this. So keep this. This will be tomorrow's assignment. Okay, your assignment is going to be student journal, page, let me find it here,